So this is the block that you're using, aluminium block. You need a weighing scale to weigh it, okay? And I need a heat-proof mat for the day. Why do I need a heat-proof mat? It's going to get hot. So risk assessment, again, when something gets hot, okay, heat-proof mat, always a good thing. You don't burn anything under. Also, another risk assessment. You were asking me about risk assessment. Go on. What's the other risk assessment? Especially when to do with heat and high temperature. Use low voltage. Am I going to use 1,000 volts? No, that's it. Seems silly, yeah, it sounds, but that's marking the exam. So that, what do I now need? This is what my immersion heater looks like. And here's the oil bit. So before I put it in, and you can see how oily it is. I'm going to have to wash my hands later. Put a bit of oil and then immerse it in. Why? Where do you want the heat to go? Onto the block. But there's air in between. And how could there be a convection and the heat will be lost to the surrounding, yes? You could, yeah. So we want all the heat to go into the block, not elsewhere. And for that, we've got something else. What's this then? That's your insulation. Like insulation around it. More insulation around it. So that needs to make a complete circuit, right? So here's my circuit. So what do I need to connect that to? Power supply, a complete circuit, okay? And on this topic of complete circuit, what am I missing now? I'm going to connect my ammeter and the voltmeter. Again, like I said, marks an exam. So you could have any type of voltmeter. We have got the easy read voltmeters. And for the voltmeter, watch what I'm going to do. 2 wires in parallel. So one across this one. One across that one, it has its own loop. It's in parallel. But when it comes to the ammeter, guess what I need to do? I only need 1 wire for the ammeter because I'm going to break the circuit anywhere. Let's say I break the circuit before it goes into the power supply. There. And then it goes into here. Right. What else is missing? Yep. A switch. I'm going to use the switch directly from the power supply. A thermometer. Again. Thermometer, good thermal contact. I've got oil on the table. Remind me to clean that up later. A bit of oil, and that makes very good thermal contact. What do I need now? What other equipment have I missed? Stopwatch. Now, would you start heating and timing straight away? This is heating up. The temperature is going to go up. Note my initial temperature, which is always the same, the initial temperature. And then, with a certain amount, so I'll read my, okay. This is 1.34. My voltage is 4. I'm going to turn that off because I'm going to let that heat up and I start my timer. Do I start my timer straight away? No, because the heat needs to be transferred to the block and then onto the thermometer. So the oil allows that nice thermal equilibrium. This is what we're going to do, right? Actually, I'm going to make it easy for you. You need to know this method. There's another better method. Yes. An ammeter. A voltmeter, and time gives you energy, doesn't it? I could scrap volts, amps, and time all together. I don't need all of that. Don't need all of this. My joule meter. So I'd use my power supply, comes in here, and then this joule meter will feed directly to that. You'll measure joules directly. There are 2 methods to this experiment, easy and hard. I've shown you the hard one. You guys going to do the easy one. Yes? Yes, so anytime you have a required practical, guys, my tip to you would be, remember the equation. Okay, so what you're going to get at your table in the next minutes would be these. So I need you to identify what they are, and I'm going to break it down how you do that experiment. So, Yusuf, tell me what they are. Identify which one is which.
The top left is the metal block.
That's a metal block. And can I just say, they're all calibrated, they've all been weighed a kilogram. But if you want a weighing scale to measure it, go ahead. And in the exam, they'll expect you to say measure mass. So how do we say measure mass? Using a weighing scale. Yes, so you got that. We also call that sometimes, that's just the block. And it's got 2 holes. Can you tell me what the holes are for? Next person, Aditya. Yes, which one? Oh, one is smaller diameter than the other one. Obviously, they're designed in such a way that only the thermometer will fit in. What's the other one for, Muad? Yes? It's an immersion heater. So you immerse it. That's your immersion heater. Two connectors. Yeah? Can you see the connections? One positive, one negative. It doesn't matter which way you connect positive to negative because it's only a heating effect. So don't worry about red and black at this stage. Okay? So what this experiment is using the principle of conservation of energy. Yeah? What energy is going to what? This is the electrical energy being supplied to the heater. Electrical energy to the immersion heater, and the heater is then going to use electricity to heat up. So what kind of energy? Thermal energy. How could we then measure electrical energy? Hence the power supply. Anyone knows? Energy is power times time, and that power can be current times voltage times time. Already now, there's a need to measure current using an ammeter. There's a need to measure voltage using a voltmeter. And I really like the person who said voltmeter connected in parallel, ammeter connected in series, marks in exam. So we end up with something else then, don't we? What's this? We need a timer to measure the stopwatch. We've talked about our immersion heater. What are the other things then? Yeah, well done. And what's that called? A key word in the exam. Insulation, or they sometimes call it lagging. Yeah? So just to prevent heat loss. Why do you want that? Because what you're doing, you're taking the electrical energy and you're transferring it to the block. Do you want that to be lost to the surrounding? Do you want to heat the room up? No. So we're assuming that there's no heat loss here, although there is. And in the next lesson, I'm going to tell you a bit more about heat loss. So we're left with one last thing that doesn't look too good on the picture. Anyone knows what it is? It's wax, but actually the one that we're going to use is melted wax. Or actually, we're going to use oil. Why are we using oil? Okay, I'll tell you what, when we do the experiment, I'm going to go over this when I do it at the table. The electrical current is I times V times time is equal to M times C times change in theta. Look what I'm going to do. I'm going to change my equation around. So I put MC change in theta to one side, and then I'm going to keep it as I times V times T. What graph are we going to plot, guys? What measurements are we going to record? Anyone knows? All right, I'll tell you. What I'm going to do, I'm going to have change in theta and time. I'm going to plot a graph of time in seconds, temperature change in degrees Celsius. And I'm going to do what to the other variables, Lazim? You see, I've got M, I've got C, I've got I, I've got V. Guess what I'm going to do to them? Correct. What have I just done? Does anyone know what I've just done? I, V over M, C. Anyone knows what I'm trying to do? This is a bit of an A-level thing. Yeah. The directly proportional. What have I done? Starts with L. We do that in maths. Well done. I'm so impressed. This is called linearization. Linearization mean, right, you could take an equation which is for a curve, a quadratic, and turn it into a straight line. But in here, this will go on the y-axis. This will go on the x-axis. So guess what? This has to be the gradient. And this, we're going to keep the same. Independent variable, dependent variable, control. We're going to keep our current the same, our voltage the same, the mass of the block the same, which we're going to measure and keep it the same. And guess what? C is constant. So we plot a graph like that of theta against C. You work out the gradient, and this should then be equivalent to that. And you get values. What will be the only unknown? C. And then you're going to work it out. You're going to go to the internet and see, does it compare to the actual value from the internet, or what in the old days used to be in the data booklet for specific heat capacity for aluminium.